Okay, so 4.7 is inverse trig functions. Now we've talked about inverse trig before. We did a lot of it in our calculator. What makes 4.7 different than when we've talked about it before is that we're going to try to make these things functions as opposed to just having at it. So got a couple definitions, and then sine function, cosine function, tangent function, and then we'll do some practice, and I'll show you how it looks a little slightly different than what we've done. So first off, a function is a rule or correspondence that pairs each element of the domain with exactly one element of the range. So basic definition of a function like we learn in algebra. So an inverse of a function is found by interchanging the coordinates in each ordered pair that is an element of the function. Okay, great. Now, in order for a function to have an inverse that is also a function, so that's the key thing here, is that we're making these inverses functions. It must pass the horizontal line test. Now, this is the test if the inverse is a function. All right, so if we look at the sine graph, and we've graphed this thing a bunch, you can see that if you were to draw a horizontal line through this graph, it would fail the horizontal line test. It hits multiple locations. We only want it to hit it once. So what we do to force it to work is we restrict the part of the sine that we're looking at. So that's what my little piece on the side here says. We restrict the domain of the sine function when referring to its inverse to pass the horizontal line test. Number one. And then the second thing that we want to do is we want to get all possible y values without repeating. So that's why we restrict it. Now, I like this picture a lot because it kind of shows you exactly how we're going to do this and how we're going to restrict it. So we're going to start here, and we're going to say, I'm going to start at negative pi over 2. That's going to give me all these negative y values, which is what I want. And then I'm going to end at positive pi over 2. That's going to give me all the y values, positive y values that I want. I'm not going to repeat any. Everything's just in this nice curve. And that's how I restrict my domain. It's awesome. So I would say like the restricted domain would be negative pi over 2 to positive pi over 2. I'm using this notation like as a reminder. When we talk about brackets, that means to include. And when we talk about parentheses, that means don't include. We don't do this a lot in this course. This is a lot more when you talk about like domain and range. It's really the only time you're going to see it. But parentheses, don't include. Brackets mean include. So that's the idea. That's how we're going to restrict this domain. And the graph underneath it is actually the graph of the inverse sine, not the graph of what we have up here. It's the inverse. This is the inverse of that. So little tongue twister kind of thing. So, but this is what the graph of the inverse sine looks like. Kind of similar, but you can see at negative pi over 2, negative 1, when we inverse it, that would look like negative 1, negative pi over 2. Remember, the coordinates all flip. So notation used for inverse sine, we see it a lot. We've seen it a lot already. Sine inverse x, arc sine of x. And then you may see this, kind of depends on how far you go in your math. I've seen it when we talk about sine inverse, they use a capital S to restrict domain. So sometimes they like to make that distinction, and they'll use a capital S to do that. So the domain of the inverse sine function, all the x values you get are from negative 1 to 1 for the inverse sine. So domain is negative 1 to 1. And then the range is going to be negative pi over 2 to positive pi over 2 for the inverse sine function.